we have to parametrize, in other words, write a system of parametric equations for an equation, a Cartesian equation here that kind of looks a little bit messy. And if you remember when before we found the independent variable and just set that equal to t, that's not going to work so well here. Instead, we're going to use this little note that we talked about in class. Okay, and this is for a certain set of a certain type of equations. When you see an x squared and a y squared in it, that's a clue that you should use this method. And really what we're talking about is circles and ellipses. So let's go about changing this equation into something that looks more like this. Okay, and it's a pretty easy rewrite. All I need to do is divide each side by 4, and that'll get me there. Okay, so it's x plus 1 squared divided by 4, and y minus 6 squared divided by 4. The right side just equals 1. Okay, so now it should be pretty easy to identify what's a, what's b, what's k, and what's h in here. Okay, as you look at the equation, you'll see a equals 4, a squared equals 4. That means a equals 2. Likewise, b equals 2. H, see, I covered these up now. There we go. H equals -1, and k equals 6. Now, let's use the second part of the note. Let x equal h plus a cosine t, and y equal k plus b sine t. Okay, so I say x equals, now h is -1, plus a, that's 2 cosine t. And y equals, let's see, k is 6, plus b, which was 2, sine t. Okay, and that's it. That's our answer. Now, it may seem a little simplistic and you're not really sure where this is coming from, but if you would like, if you feel more comfortable, say, squaring both sides and eliminating the cosine squared plus sine squared, that Pythagorean thing, that's fine. You'll end up with this guy if you want to go backwards. This is just a method that should save you some time in a whole category of problems where you have x squareds and y squareds. Now, if you've been through a conics course recently, or it's been a while, you should still recognize that this is a circle, right? When you have two equal coefficients down here, this divided by 4, or when you have a radius squared over there and there's no coefficients in front of the x squared and the y squared, this guy is a circle. Now, sometimes they're going to be ellipsoids, which is this next example. Okay, but we're going to follow the exact same method. First, let's rewrite this in this form. Okay, let's call this our standard form. And I need to divide both sides by 225 first. See, I want that 1 right here. So I'm going to divide both sides by 225. So I have 9x minus 4 squared over 225 plus 25 y plus 1 squared over 225 equals 1. Now I can simplify that a bit. Let's see, 9 over 225. I know 225 is divisible by 9 because 2, 2, and 5 add up to 9. I just can't quite remember what it is. 225 divided by 9. Oh, that's dumb. Okay. It's 25. So I get this. X minus 4 squared over 25 plus, and this one simplifies also to 9. It won't always be pretty, but in these examples, I think I made them so they wouldn't give you too much hassle. And now if you look at this equation again, remember, I want A, I want B. Well, A is equal to 5, B is equal to 3. Because 5 squared is 25, 3 squared is 9. Now if you look at the H and the K, well, where are those located? H goes with X. Okay, so that's going to be 4. And K goes with Y, so that's going to be -1. And now I simply rewrite according to this formula. X equals, let's see, H is 4 plus 5 cosine t. And Y is K, so that's -1, plus B is 3 sine t. Remember, if you're unsure about whether you did it right, you can always just go ahead and plug this stuff back in. and try to get it as a Cartesian equation instead of a parametrized equation.